This is our final section of geometry for this year, your last set of notes. It is 12-4, and in this case we're going to talk about angle measurements and segment lengths pertaining specifically to secant lines. So we'll get to that here in a minute. So listed right above, or right in the beginning here, are your two formulas that are going to drive most of this material. Now the only difference is it all depends on where the intersection of the two lines occur, okay? So the formulas, if you look at them, are extremely similar. The only difference is one is a plus sign between x and y, one is a minus sign between x and y. It is a plus sign when the intersection occurs inside of the circle. So if you have two lines that cross anywhere inside the circle, you're going to add the arc measurements together. And then if the intersection, as you see illustrated here, if the intersections occur outside of the circle, then you subtract y from x, okay, or x minus y. So the word secant is a line that intersects a circle at 2 points. I think of secant as different from a tangent line. Secant hits it a second time. That's how I differentiate between the two. But your test is going to be, not too heavy on vocabulary, more of can you simply solve one of these things. So as we take a look at our first example, the first thing, before I even look at it, obviously the directions say what is the value of each variable, but the first thing I need to understand is where is the intersection occurring? Are the two lines crossing in or outside of the circle? So in this picture, very clearly the intersection is occurring on the inside of the circle, all right? It occurs right here, okay? So that tells me my formula is going to be 1/2 of x, y is going to equal the measurement of the angle. Well, just like it's stated up here, right, when the intersection occurs outside of the circle, when the intersection occurs inside of the circle, I'm going to add my x and y. Okay, and x and y, of course, are your arc measurements. So in this case, my formula is simply going to be 1/2 of 46 plus 90. And your calculator, just go ahead and type that in, and you will get that the angle measurement is 68 degrees. All right, it's that easy. Okay? For your next example, in this case, the intersection is occurring outside of the circle, so my formula is 1/2 of x minus y, because the intersection is occurring outside, is equal to the measurement of the angle. Now, this is the only reason why this can get kind of tricky. X and y are your arc measurements. So x and y, one of them would be this arc measurement, and y would be this arc measurement. Well, in the case of the problem, well, the 1/2 is a constant, that doesn't change. The big arc, which is 95, minus this is a variable. The angle measurement is 20 degrees, so that's your setup, right? These two parts represent your arc measurement, but I'm looking for one of the arc measurements, so I'm obviously going to put a variable in place for that. So in order to solve this, you have two choices. Me personally, I would do the first choice, which is to get rid of your fraction. Clear your fractions, multiply both sides of the equation by 2. That clears this out altogether, and then that allows you to not have to deal with fractions at all. You could, if you wanted to, you could distribute the 1/2 through, but dividing 95 by half, and you still have half of a z, I wouldn't want to mess with that if I don't have to. I'm just going to get rid of the fraction from the get-go. So when you multiply 2 by half, it cancels. When you multiply 2 by 20, you get 40. So now you have 95 minus z is equal to 40. Minus your 95 from both sides. You have negative z is equal to negative 55, which means z is equal to 55 degrees. Okay? All right. The next example would be one that I would have you do on your own. So if you would like to, pause this, try it, and then compare it to what I get. So in this case, again, the intersection is occurring outside of the circle. So I have 1/2 of x minus y is equal to the measurement of the angle. Well, in this case, the bigger arc is my variable. So I'm going to leave x as x, or if you want to call it w, we can do that too, minus my 110, because that is the smaller arc, is equal to the angle measurement, in this case, of 70. Again, I would not distribute the 1/2. You can, but I think it's easier to simply just multiply both sides by 2. Okay, that clears this. W minus 110 is equal to 140 because 70 times 2 is 140. Add your 110 to both sides. W is equal to, 250, not 150, 250. Okay. All right, and then again, I would have had you do both A and B. So again, if you want to pause, this is a very straightforward one, and try it out. Your intersection is occurring outside, so again, it's minus. So x minus y is equal to the measurement of the angle. So in this case, my big arc is 110 minus my little arc is 30. That's going to equal, so I'm just going to do the math here. This gives me 80. Half of 80 is 40. So your answer there is 40 degrees. And then last but not least, for this part of the notes is your last example. And this intersection is occurring inside, so my formula is going to be x plus y is equal to the measurement of the angle. Well, my two arc measurements, one is a variable, one is not, so I'm going to replace y with 30. And the angle measurement is 35 degrees. So again, I would multiply both sides of this by 2. I get x plus 30 is equal to 70, minus my 30 from both sides, and x again is equal to 40. All right, so again, the formula is very easy. It's addition if the intersection occurs inside of the circle. It's big arc minus little arc if the intersection occurs outside of the circle. Hopefully the algebra there isn't too challenging for you. Moving on here to our last theorem. In this case, it's going to, they look tough, and there's a lot of them, and it feels like it's confusing. But again, you know, if the intersection, let's read the formula, the theorem first here. For a given point and circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point in the circle. All that means is you can set up, you know, if these two lines intersect inside the circle, this part of the chord times this part of the chord is equal to these two parts of the chord multiplied together. Okay? The intersection occurs outside. This is where it gets a little bit tricky. You take your two parts of the chord, so this part, so x plus y, and then you multiply it by the value outside of the circle. So x plus w times w is equal to z plus y times y. And this is really the exact same thing. You know, this is going to be z plus y times y, because y is the part outside of the circle. And because this line is tangent, the formula says t squared, but that's really, there's nothing inside the circle, so you have 0 plus t times the part outside, which ends up giving you just t squared. Okay, so again, if that doesn't make sense to you, you're going to obviously have the formulas on your test, so just what problem matches, this problem looks like this example, so I'm going to look at this example to solve that equation, right? This one looks very similar to this setup, so I'm going to use that formula to solve this, right? Okay, so like I said, for your first example, this looks exactly like this part of the theorem, so I'm going to apply that. So the formula simply is, let's do the top secant line first, 6 plus 8, and I just multiply that sum by the part outside of the circle, is equal to 7 plus y times 7, because that is the part outside of the circle. When I do this on the left, 6 plus 8 is 14 times 6 gives you 84, is equal to, now this you do have to distribute. That gives you 49 plus 7y. Okay? Minus your 49 from both sides. You get 35 is equal to 7y. Divide both sides by 7, and y is 5. Okay? Your second example, B. We'll do this in red. So like I said, this matches this part of your theorem. So we're going to model that. So this is the same part as before. So 8 plus 16, 8 plus 16 times the amount outside of the circle, which is 8, is equal to simply z squared. When you add 16 and 8 and multiply it by 8, you get 192. And z squared obviously isn't going to change. Now to solve this, it's not asking for an exact answer, it's asking for a rounded answer. So you can square root this in your calculator, and you get z is equal to about 13.9, depending on where you round. The directions did not say, so if you round in the nearest tenth, it's about 13.9. Alright, and then these would be the last two examples I would have you do on your own. So you should pause it, try it, and then obviously check. But this models the theorem part number 2. So I'm going to do my 20 plus 14 times 14, because that part is outside of the circle, is equal to x plus 16 times 16. When I do this, I get 34 times 14 gives me 476 is equal to, and now when I distribute 16, 16x plus 256. Minus your 256 from both sides. That gives you 220 is equal to 16x. Divide both sides by 16, and you get 13.75, which if you were to round it, it would give you about 13.8. Okay? And then your last example, now the only reason this one's tough, first of all, this resembles part 1 of that last theorem, but the only reason why this could possibly be tough is because you're unsure of what part is which. This part right here is your 3. This part right here is your m. Okay, so when I go to set this up, this is just, parts times parts. So if I look at, let's stick with the blue here, 6.5 and m are the two parts of that chord. So 6.5 times m is equal to, and then the parts of this chord, 7 times 3. So that gives you 6.5 m is equal to 21. Divide both sides by 6.5, and m comes out to be about 3.2. Alright, so you have really the rest of this week to get this in 12.3 done and get all your questions that you have into me. I will post answers to questions as I get them. And then next week, your only assignment, you'll have all week to do it, and I assume none of you are going to work on Monday. But you have all week to submit a very easy quiz from 10.6, 12.1, 12.2, 12.3, 12.4. Expect 1 or 2 questions from each section, and obviously nothing more than that. All right. As always, if you have any questions, shoot me an email, and have a great holiday weekend.